Assalamu alaikum. Last week we started with the chapter 18, magnetic field created by an electric current. We talked about the first three objectives. Now, in this part, we are going to explain two additional objectives. First, we will start to determine the characteristics of a magnetic field created at the center of a circular wire carrying current, and we will study the case of a flat coil. After, we will go to determine the characteristics of a magnetic field created inside a solenoid carrying current. Now, let's start with magnetic field created by a circular wire. We have two different cases. First, case of a circular loop. If an electric current traverses a circular loop, a magnetic field is created. This is the form of the circular loop. It's important to know that the magnetic field inside the circular loop is not uniform. As you see in the adjacent drawing, this is the circular loop that carry current, and these are the magnetic field lines. As you notice, the magnetic field lines don't have the same direction and don't have the same form. So, the magnetic field at two different positions don't have the same characteristics. As you notice, the field line passing through the center of the circular loop is a straight line perpendicular to the plane of the loop. In addition, as you move away from the center, the magnetic field decreases. So, the magnetic field at this point is much greater than the magnetic field at this point, since the magnetic field and the distance are inversely proportional. We are only interested in the magnetic field at the center of the coil. This is the center of the coil. Now, we want to characterize the magnetic field created at the center of the circular loop. We have four characteristics. 1. The origin. It is the center of the loop, as you see in the following drawings. 2. Line of action. It is perpendicular to the plane of the loop. Look here, this is the line of action, and the same in this drawing, it is perpendicular to the plane of the loop. 3. Direction. It is indicated by using the right hand rule. You know it, but I'm going to recall it soon. 4. Magnitude. It can be calculated by applying the following rule: B equal mu0I over 2R, where mu0 is the permeability of a free space, which has a constant value 4 pi times 10 to the power minus 7. I is the current traverses the loop in ampere. R is the radius of this loop in meter. Remark 1. How to apply the right-hand rule when an observer is in front of a loop. For example, this is a circular loop that is traversed by a current. To determine the direction of magnetic field created at the center of this loop, first, curl your fingers of your right hand in the direction of the current. Then your thumb will direct it away from the observer, away from you. So the magnetic field goes away from the observer, and it has the symbol cross out. So when the magnetic field has a symbol cross out, it means that it is away from the observer. In the second picture, this is the direction of the current. Let's try it, my student. Curl your fingers in the direction of the current, so your thumb will direct it towards the observer. So the magnetic field has a symbol dot. So dot is the symbol of the magnetic field when it is directed towards the observer. Remark 2. To determine the nature of the faces, we can use the arrows added to the extremities of the letters S and N. We have two circular loops. The first loop is traversed by clockwise current. As you notice here, the direction of the current has the same direction as arrows added to the extremities of letter S. So we can say that this phase acts as south pole. Therefore, the magnetic field going into the plane of the loop, represented by cross out X. The second loop is traversed by anti-clockwise current. As you notice, the current has the same direction as arrows added to the extremities of letter N. So we can say that this phase acts as north pole. Therefore, the magnetic field going outwards from the plane of the loop, it is represented by dot. This is the end of the third part, determination the characteristics of a magnetic field created by a circular loop, plus some remarks.